Guys, I just grabbed some problems out of the book. Here's this is number 26 at 5.3. So let's consider the function x squared plus x minus 4. We're going to estimate the area between the graph of g of the x-axis from 2 to 4 using 4 rectangles and right endpoints. We're going to sketch the graph and the rectangles. Then we're going to repeat it doing left endpoints. So we're basically going to do the same thing we just did, but with x squared plus x minus 4. So to speed it up a little bit, I'll go ahead and use the calculator to get a graph. So it's x squared. Look how short that is. X squared plus x minus 4. Sabotage. Well, actually, I can't find that 4 very close to the x. You can't try to see that. It's much the x and 4 popped up. All right, we want to do it from 2 to 4. Maybe this time I'll just change my window and go from 2 to 4. And I'll hit zoom fit. It almost looks like a straight line, huh? And we better get in here. See, it's not giving us the y or x-axis, so I better let the y go down the data line. I want to see the the x-axis. So there we go. There's our function. You know, maybe for this too, maybe I'll go 1 to 5. Just to get a nicer picture. 1 to 5. So take a picture of this twice because we want to do it twice. So here we'll do part A here. We'll do this with right intervals. So this right here is 2. Right? And 3 and 4. Again, if we're going from 2 to 4, we want 4 rectangles, then we want the width of each one to be a half. Right? Because we would do 4 minus 2 over 4. Do the change in x over the number of rectangles. So to find your width of the rectangle, you want to figure out the change in x and put it over the number of rectangles you're going to do. So if we do right endpoints here, we're going to go to 2.5 and 3.5. This first rectangle, I'm going to use this for my height, and I'm going to make a rectangle. Then I'm going to go from 3 to the function to make my rectangle. Then from 3.5 to the function to make my rectangle. And from 4 to make the rectangle. So here I use right endpoints. Notice how when a function is increasing, whenever you use right endpoints, your estimate's going to be too big. Right? Because you're always going to go above the rectangles. But we could approximate this area here. The area of a rectangle is the base times the height.
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 Yes.
Isn't that what I always say?
No.
What do I say?
Height.
Height?
Yes.
Height 1, height 2. Football season's over. Well, the Rattlers are playing now. You know who the Rattlers are? Arena football? That's exciting. All right, so the height. We're going to take the base times the height. Every one of these, I'm saying height.
It's great.
Yeah, I'm making sure.
Yeah, think about it.
I don't like to be mocked. But I don't mind it when it's funny. So, because we could go through and do the width times the height, width times the height, right? Or we could factor the widths out, right? It's always the width is going to be the same. So we can factor that out and then just take the sum of the heights. So here, this is 2 to 3, so in between there, this is 4 over 2, this would be 5 over 2, right? 6 over 2, 7 over 2. So our function, because the function is x squared plus x minus 4. So the height of this rectangle would be g of 5 halves. The next one would be g of 3. And the next one would be g of 7 halves. And then g of 4. So this one's not as nice as that other one that was just plain x squared. So maybe somebody go ahead and help us out here with your calculator. What is 5 halves squared plus 5 halves, or minus 5 halves plus 1? 19 fourths. What about when you put in 3? Is it 10? So yeah, what we're doing is we're putting these numbers into this. So 3 squared is 9. Actually, this plus 3 would be 12. Minus 4 would be 8. And then when we do 7 halves, it would be 7 halves squared plus 7 halves minus 4.
This is gonna be on the list of the next part of the test, right?
You tell me you couldn't do that? I'm just trying to
See
speak.
my test? I know.
Well, 7 halves squared would be 49 fourths, right? Plus 7 halves minus 4. Should have used. So, what, 49 fourths plus 14 fourths minus 16 fourths? This would be negative 2, 49 minus 2, 47 fourths.
I mean, yeah, I can do it, it would just take me like forever.
Forever? That's a very long time. What if we said, okay, Aaron, then we would just make it like a plain x squared or x cubed without a number.
As long as it was a half, not like,
So that one's 47 over 4. If we put 4 in there, we get 16 plus 4 is 20, minus 4 would be 16.
So you're just going to the whole test by
So 72.5, what was that, 145 over 2? So, Bailey say it should be 145 over 4, which is 36.25. People confirming that? Okay, so that would be using right endpoints. Now, if we got to do it using left endpoints, then we just go, okay, here's 2. We make 2, 2.5, 3, 3.5, 4. And we use the left-hand side for our height. So we go 2 to find our height, then at 2.5 to find our height, and then we find our height at 3. And then at 3.5. This time our estimate's going to be a little too small. Right, but now once we've done it once, the second one is a little easier. Right, the widths are a half. And then this one now, the height is at 2. Right? So we do g of 2. Plus the next one we do g of 2.5 or g of 5 halves. Then g of 3, and then g of 7. So this is going to be exactly the same as the right endpoints, except we didn't start here, we started at 2. So if we put 2 in there, 2 squared is 4, plus 2 is 6, minus 4 would be 2. Then we've got our g of 5 halves, that was 19 fourths. Our g of 3 was 8, and our g of 7 halves was 47 over 4. So what's that final answer? So 40, 59, 99, 106, 106 over 4. Are you just saying that?
No, I did it in my head.
So 53 over 4? Could be 12, 13, and 1 thing. 113.25.
Right,
Calculator confirmation.
yes.
So Aaron, what do we know about the actual area? It's somewhere in between those two, right? Yeah, well, if you look at our rectangles, look at how much, look how much above this one went and how far below like this one was. So we've got that big of discrepancy. Now we can actually find that actual area. Right? Terry says he's seen it before, so he's going to see it again. I calculate the interval and then go from 2 to 4. Look at 16 and 2/3 is the actual area. Yeah. Well, it's because Casey's got a good question. Why, in both of these, it turned out, Bailey pointed out the other one, that the left endpoints or the underestimation was closer to the actual area than the right endpoints or the overestimation. Why is it? On the calculator? It's, you can go into calculate. So second, calculate, number 7 for interval. And then it will ask you lower limit, upper limit. That's just where we're starting and stopping. So it was from 2 to 4. And then it finds it. Who's
I think it depends on where we're looking at the graph. This is the parabola.
Well, the thing, does it depend on where we're looking, or does it depend on what the graph's doing?
Well, yeah, because when you're higher up on the graph,
I depend, yeah, it depends on the type of graph, the nature of the function.
Or-
Whether or not it's over or under.
So I think, in a roundabout way, I think what you're saying, if the graph's increasing, the further out we go, the higher this is going to get above when we do the right endpoints than it was before. Right, so if you look, every time this got bigger above, and this got, there's more that we're missing. We're missing, well, I don't know if that's making sense, but as we went out further, the graph gets higher as it's increasing. Right? If the graph was decreasing, if it was a graph that went like this, if the graph curved this way, and we started drawing our rectangles, I said decreasing. If the graph was doing something like this, or if the graph's going like that, it's then when we draw rectangles here, the left endpoints are going to be too big, right? And the rights would be too small. Then the right ones would be closer, because the smaller you go, the smaller the rectangles get, and the less off there. All these things. Uh-oh. I got that from Bailey. I don't want to come over the bus. So this would be 24, right? So multiply by 4, 96 over 4. 96 plus 47 is 136, 153. 163, 172 over 4. Uh-oh. 62? I could be wrong. Terry, why don't you say something? If you know something, don't keep it to yourself.
Well, so if I point out all your mistakes.
So, but you're getting 81 over 2. See, that's why we need active participation. Thank you. Thank you for breaking your vow of silence. Yeah, this should have turned out to be, actually, that it's, before we reduced it, it's 162 over 200. Over 4. Yeah, and then 2 goes to 162, 81 times. Yeah, that's a lot closer to what we have, and still, the 13.25, actually, is the 13.25 closer? They're pretty close here, huh?